All right. Let's go ahead and read. A cannonball with an initial height of 1 meter above the ground is fired from a cannon at an angle of 50 degrees above the horizontal. The cannonball travels a horizontal distance of 60 meters to a 10-meter high castle and passes over it. It has like 2 meters of clearance above the highest point of the wall. We're going to ignore air friction, and we first need to determine how much time it takes for the ball to reach the wall. A hard problem because it feels like we don't have enough information. I'm going to start by drawing a picture. So there's my flat line. Thank you, technology, for fixing that. And for some reason, we have some sort of elevation for a cannonball, and we have some sort of wall over here. So we know that this is going to be an initial height. I'm going to call this my y initial is going to be 1. And we know that we have this is a 10 meter wall, sorry. Everything's in meters, so. And then we have some clearance here, because the cannonball is going to be right about here, which means we have another 2 meters of clearance, so for a total of 12 meters. Okay, we also know that when it shoots out of the cannon, I apologize for my terrible drawing skills. There's my cannon. This angle right here is 50 degrees, at least at first, until the final part down here where we have 55.5 degrees. Am I missing any information? Oh yeah, and then it goes 60 feet in terms of the x distance. So I can say that this distance down here to the wall is 60. I might always say feet, meters. My apologies. All right, so how do we do this? And I'm realizing we've wasted a little bit of space, so I can move you guys. Oh, I don't want to move the picture up though. Can I grab that without grabbing the picture? Okay, without wasting space. So the first equation that I'm going to be using is I'm looking at my notes to make sure I do everything correctly, my y. So my y component is going to be equal to my initial y plus my velocity for my initial y, and then I'm going to multiply that by t minus 1/2 gravity times time squared. And I apologize, I don't take physics. I'm just looking this stuff up online. So if these isn't the notation you're using, then hopefully it'll work. Okay. My other equation I'm going to be using is x. My x position is given by my initial x, which in our case is going to be 0. So I can go ahead and cross it out. I'm not like moving my cannonball to the right or to the left, right? I'm just keeping it here at 0. And then I'm going to say that is going to be plus, I'll go back to red though, plus my velocity in my x direction times time. From that alone, we should be able to solve that first part. So I guess I should notate that I'm solving for part A here. So I'm trying to stay organized. Right now I'm solving for part A. Okay, so for the y coordinate, let's plug in what we know. We know that we're going to end up at 12 meters high. We know that our initial y is 1 meter above the ground. We don't know our initial velocity, but we do know that the velocity, I can say that this is the same thing as whatever our initial velocity is times the sine of our angle. And since we know that our angle is 50, so I can cross that out again and say that's really 50 degrees. And that means if I'm writing in our formula down here, I'm going to say this is going to be plus our initial velocity times sine of 50 degrees. And I have to multiply that by t. Multiply by t. I should go back to red though, huh? Multiply by t, and I subtract 1/2. And since we're in meters, this is going to be 9.81. And then I'm going to multiply that by t squared. Cool. Filled in all the information on the left. Let's fill in all the information on the right. We know that we travel a total distance of 60 meters. So I'm going to say 60 is equal to, I have that's 0 that I don't have to worry about, plus we don't know our velocity in the x direction. But again, kind of like last time, I'm going to say it's our initial velocity times cosine of theta. And again, we know that theta is equal to 50 degrees. So that means I'm going to say that this is going to be plus cosine of 50 degrees. And don't forget that this is all being multiplied by t. All right, so as a general rule in mathematics or physics, if you have two unknown variables, look, I have a vi, a t, and a t, And over here, I have a, whoa, what happened to my VI? Oh gosh, I need to fix that, don't I? Let's move you over, make some room. VI. So if I have two variables, there's a VI, and the second variable is t. If you have two variables, you need two equations to solve. And I have two, what is the term? Linearly independent equations. So this should somehow solve for t or for v. And because part A is asking for, where is it? How much time? Let's go ahead and eliminate the VI variable, and we'll solve for time. So I'm going to go ahead and solve this for VI, and then set them equal to each other. So let's go ahead and say, okay, if I'm solving for VI, I apologize for going fast here, but I'm going to subtract the 1 on both sides. So if I subtract the 1, that's going to give me 11, and I'm going to add this whole term to both sides. So I'm going to say 11 plus half of 9.81 t squared. And what's left over is all of this term. And we want to solve for VIs, the initial velocity. So let's go ahead and divide by sine of 50, divide by t. So I'll say that's going to be all divided by sine of 50 and t. Cool, so what we've done there is we've solved for our initial velocity. I don't know if velocity is supposed to be capital or lowercase, I don't know, I don't take physics, but whatever. Same thing on the right hand side, right? I'm going to solve for VI. So I'm going to kind of move all this stuff to the other side. Here we go. I'm going to say that this is 60 is equal to, okay, well, hold on, 60, I think I can just divide each of these, right? Divide by cosine 50, divide by t. Yeah, let's go do that. So I'm going to say 60 divided by cosine of 50 and divide by that t as well. And that's going to be equal to also my initial velocity. So since these are both equal to initial velocity, I can say that this equation and this equation are equal to each other. So let's go ahead and say that. I have 11 plus 1/2 of 9.81 t squared. Wait, I have copy and paste. Why am I rewriting it? Whatever. It's good practice. T times sine of 50. And that's going to be equal to 60 over cosine 50 times t. Oh, I should put the t out front like the last one, huh? So put the t right there. And at this point, I'm going to go ahead and say, well, there's t on both of them. So I'm going to multiply this side by t, assuming that t isn't 0. It's not, because it takes some time to do stuff. Those are going to both cancel out. So t and t is gone, t and t is gone. And I have our new equation. I'm going to go ahead and cross multiply. So when I cross multiply in this direction, oh god, cosine 50, distributing to all of these terms, whatever, I have 11 times cosine of 50 plus, distribute again, I have cosine 50, so it's going to be, I'll just put it up front, cosine 50 times 1/2 times 9.81 times t squared. That's on one side. On the other side, when I cross multiply this direction, I just have 60 times sine of 50. Okay, this can be solved because it's essentially a quadratic. It's essentially, this is like an x squared. There's not even another x, so it's kind of an easy quadratic. So let me reorganize this. I'm trying to reorganize this into like an ax squared plus bx plus c sort of equation and make sure that's equal to 0, because if I do that, then I can use the quadratic formula. I'll write it, quadratic formula, which basically says that you can solve for x, which in our case is going to be t, and that's going to be equal to, there's a song, right? I'll sing the song. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And we just plug and chug. So my goal right now is to turn this into something that looks like that. Here we go. And I'm running out of room, so I'm going to write it off to the side here. I'm going to have all of this junk. So it's going to be 1/2 cosine 50 times a 9.81. That is my, this right here is going to be my a. Oh, without the t. That's going to be, come on, write better. That's going to be my a in front of my x squared, plus 0 t, because there's no t, so that means that this 0 is my b. And then finally plus, man, I'm always running out of room. Maybe I can just write smaller. Maybe I can grab all of you guys and send you, aha, do I have, This is not as much room as I had. All right, so plus, here we go. It's going to be 11 cosine of 50 minus, I have to move this 60 of the other side, so I'm subtracting that from both sides. So I'm saying subtract the 60 sine of 50. And that entire gross term is going to be my c. At this point, I plug and chug. In my class, in my math classes, I allow the use of Desmo Scientific Calculator, which is what I'm going to be doing. So let's go ahead and switch over to my scientific calculator. I already have those set up because I knew that this was going to be a quadratic formula. Now I can just type this in and figure out what I'm going to get. So I'm going to have a is equal to, dear gosh, here I go, 1/2. This is going to be times cosine. I could just type in cosine right here. Cosine of 50, and the parentheses, times 9.81. That's my A. Cool. B, I already said it's going to be 0. C is going to be 11 cosine of 50 minus 60 sine of 50. Sine of 50. And cool, we're done. It's notice that there's two equations up there. Can I just screenshot and add that to my, let's see, can I use technology correctly? I just want to show you guys, when I plug that in, there were two equations. That's good enough, so we'll copy that, and we don't need that anymore. So when I come back over here, I can now, probably paste this kind of small. I can say, okay, well, in this equation, obviously, we're not going to have a negative time. We're going to choose a positive time. And I think in the solutions that were posted on Reddit, this was one of the two solutions. So I'm going to go ahead and save that in my calculator by saying that that is equal to, I'll say something like this. I'm going to call that time. Time is equal to 3.51 seconds, and I'll store that so I don't lose any accuracy. That's only part A. Did all that work for part A, but because we did all that work, it's a lot easier. Let's move on to part B. Let's go ahead and reread it. In part B, it asks to determine the initial speed that it is fired. It's not the initial y component speed or x component speed, so we have to like do a little bit of extra math. So coming over here, if I'm, again, the question, I'll restate it for part B, is what is, I don't know, to use S for speed, what is speed? And I know the equation. S, the speed is equal to the square root of the velocity of the x squared, and then plus the initial velocity of the y squared, and you just square root those. We kind of have those, right? We have, I can sub these out and I can say that the initial velocity of the x, as a terrible arrow, is going to be the initial velocity, which we don't know. Oh, okay, so we know how to get the initial velocity though, right? Hold on, before we do that, we are going to eventually do this, so I'll finish this, times cosine of theta, and then this is going to turn into the initial velocity times sine of theta. We need to figure out the initial velocity. Wait, isn't that what is the question asking for speed or velocity? Oh, okay, yeah, so I think I'm doing this right. Let me check my notes. Oh, this is, okay, I'm being silly. We're not doing that until, part C is asking that though, right? Part C, determine the velocity as a passive. Okay, we don't need, if it's just initial speed, it's just the initial velocity. I super apologize. Ignore everything that I just said. I don't know what I'm talking about. I just want the initial velocity as it comes out of the cannon. So in that case, I'm going to use that equation that basically said that to get our x position, we take the x velocity and we multiply that by time. Well, we know that the x velocity is going to be, as I said before, it's going to, do a different color here. This is going to turn into our initial velocity, the thing, or the initial velocity times cosine of theta. So I can just fill in and I say, okay, I'm going to travel 60 meters, and this is going to be equal to the initial velocity, which we don't know, times cosine of the angle, which we do know, which is 50 degrees. And that's going to be multiplied by a time, which we do know because I'm going to save it in the calculator. So I'm just going to say, what did we say that was, about 3.512? 3.512. and I can just solve for initial velocity by dividing by these two terms, right? So I can say, yeah, divide by those two terms, blah, 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 and then you get, I should write in pen, that the initial velocity is going to be equal to 60 divided by cosine of 50 times, I'm not going to say t because I'm going to store it as a variable, but 3.512. So calculator, come save us. Calculator, where are you? So let's see if I can write this. So it's going to be 60. I'm going to save this as t though. So come up here and say that this is going to be, t is equal to that value. We're going to save it. So down here, I'm going to say 60 divided by, that's the wrong function, cosine, thank you, cosine of 50, and I'm going to multiply that by t. I'll just put the t up front. So I'll say t times that. All right, and we get 26.577. So this is about 26.577. Cool. And I'm going to store that because that's kind of important to know. That's going to be my initial velocity. So I'm going to call that thing vi is equal to that. Will that work? Okay, I'll just say, can just say v. All right, v is going to be that variable. Cool. Then I can move on to part C, which is the one that I was getting mixed up with for part B. So part C is asking for the velocity as it passes over the castle wall. Right. Okay, so the velocity at any point for x is going to be the same thing no matter what, right? It's always going to be your initial velocity times cosine of your angle. So in that case, it's going to be, in our case, 26.577 times cosine of 50. Pretty easy peasy. The velocity of the y, it's a little bit more troublesome. Where'd that formula go? The velocity of the y is the initial y, and then you have to subtract the gravity times time. But we know all those things, right? Because we know that the initial y is really going to be our thing that we just found, I keep calling it v0, but the initial velocity, or I guess, yeah, the initial velocity times sine 50. And we know that time up here is going to be, what did we say it was? 3.512? 3.512. We can just figure all this stuff out really quickly. So I can say that, maybe go back to red here, that velocity in the y direction is, I don't want to rewrite all those things out. I'm just going to calculate it. Calculator, come back. Thank you. Please. All right. So this is going to be equal to, so I'm going to say I'm going to call it x because I'm lazy. It's really the velocity in the x component. I'm doing that first equation is equal to the original velocity that I found, and I'm going to multiply that by cosine of 50. Cool. And I can write that down. So this is roughly equal to 17.083, all over the place with my rounding. 3 decimal places is kind of the consistency, I guess. Okay. And then what about our Vy? Well, that's going to be equal to, I'm going to call it y because I'm lazy. It should be the velocity with respect to, or velocity of the y direction, right? This is going to be, where's my equal to button? I guess I'll come back up here. Our y is going to be equal to, and then what did we say for our equation? Oh, it's right there. So it's going to be that v that we just found, the initial velocity, and then I'm going to multiply that by sine of 50. And then I need to multiply that, no, I need to subtract 9.81 times that t, which I stored as a variable, so times t. And we get that number. So this is going to be, again, this is really an approximation. Whoa, that was way too big of an eraser. So I just meant to erase a little bit. Thank you. This is about negative 14.095. To get the actual speed overall, you need to do that formula that I was mistakenly doing in part B, which is your, I don't know, velocity of both directions is your velocity of the x squared plus the velocity of the, well, that's not velocity, that's velocity of the y squared, and then you square root those. So I can just do that on my calculator over here. I can say x I should do the square root first, huh? The square root of, no, we'll do the x squared plus the y squared, and there it is, 22.148. So this is about 22.148. Cool. And then we move on to part D. What was that question again? Calculator, you can only have that much room. Part D. If the same cannonball is fired with the same initial speed, okay, so we don't have to do any more recalculations, but in a new angle, 55.5 above the horizontal, determine whether or not the ball will still clear the castle wall. Oh yeah, that's right, because we originally had 2 meters of clearance, so maybe it will hit the wall or maybe it'll still be above it. We don't know. So just new angle. We're essentially just calculating height. We are ignoring x, although we're going to have to use x, aren't we? Okay, so essentially we're trying to find y, and I'll show you that we'll need x in a sec. So we're trying to find our y component. So we're trying to find, okay, what is y? Y is equal to whatever that equation is. I don't have it memorized. It's our initial y velocity minus gravity times time. The problem is we know our initial velocity because we can just do sine of our new angle, but we don't know our new time because it will be a different amount of time. So we have to redo this one with a different formula, which you guys are probably used to. This is the easy part of the question with our x. X is equal to whatever the initial velocity of x, and then, times time. Okay, I thought I was doing this wrong. I wasn't looking at my notes. And we know that this is still getting, like, the wall hasn't moved. It's still 60 meters away, guys. All right, and our initial x velocity is going to be our initial velocity. It said it didn't change, right? It's still the same initial velocity, and we're going to be multiplying that by cosine of not 50, but 55.5. And then we're going to be multiplying that by t, which we're going to solve for. Like, I have all of the numbers except for the t. So I know that the VI is going to be whatever number we found for VI is going to be this 26.577. So plugging all that in, I'm essentially now saying that t is going to be 60 divided by all those things. So it's whatever that initial velocity is that I stored times cosine of 55.5. And we'll get whatever that's approximately equal to. Handwriting is getting more and more terrible by the minute. So I'm going to say 60 divided by that initial velocity. Did I call that V? I hope I did. V seems to be working, times cosine of 55.5. So our new time is about, it's almost 4 seconds. It's 3.986. 3.986 seconds. I don't know why I randomly put units on that one. Which means I'm now ready to do this final one. I can say that y is equal to, it's going to be that initial velocity times sine of our new angle, which is 55.5 minus 9.81 times that time that we just did. So do I have enough? Is my calculator just ruining my room? No, I'm just writing too big. Let me try to conserve space as best as I can. Move you right there, move you right there. I think I randomly move the t. All right, there we go. And I'm going to be multiplying by that new t, which I'll call maybe t2. We should call this thing right here, I'm going to call that time 2. Cool. Well, let's see what that is. So y is equal to, calculator, come back. There you are. So just need to type all that in. So it's going to be, oh, I want to call that thing t2. So I'll say that's t, and if I just type a 2, it should do subscript, right? t2 is equal to all that. Excellent. All right, so it's going to be equal to my initial velocity times sine of 55.5 minus 9.81 times that thing that I just did, times t2. And that's not right. What's going on? Oh my goodness, I'm using this times. This is not my equation for y. I can't believe. Okay, I apologize. Let's show you what I did wrong. This is not the right equation. This is the equation for something. That's the equation for velocity, not my y. I apologize. Can I redo that real quick? Yeah. I don't like editing videos. You get to see all my human mistakes. Let me change this into the correct equation. This is my initial y plus the velocity of my initial y times time, which I'm going to call time 2 now. And then I subtract half of gravity times that new time that I found squared. All right, so I don't know if I'll have enough room here. Maybe I'll write super duper small. My initial y, it's still 1 meter off the ground, and then plus the y component, which is going to be still the same initial velocity, times the sine of my new angle, 55.5. That's going to be multiplied by that t2 variable that I found, and that's going to be subtracting 1/2 that 9.81, which I'm just going to call g still because I'm lazy, times that new time variable squared. Okay, just type all that in. Ready, set. Can I keep any of this, please? Can I do 1 plus all of that? Get rid of this. That looks good so far. Minus 1/2, which is 0.5, times 9.81 times that's t2 variable, t2 again, and then I have to square that. Square it. Oh, okay. Well, that looks like a value that looks okay. So it's going to be 10.376 meters. And as you will recall, our wall was 10 meters tall. So the answer is yes. It will still clear the wall. The end. Thanks for watching. Sorry for all the mistakes. Later.